informations which lead us to a position circle. And today we shall learn what are the methods which could possibly be used. Not that every method is to be used every time. What are the various methods which could be possibly used to obtain the position circle? As the name suggests, what is a position circle? It's a circle on arc of which the ship may be located. So if you have a circle like this, why this pen is not working? Give me a minute. Why this pen is not working? One second. Oh, maybe it. Okay, this is not working. Guys, I'll just. Okay, one second. Yeah, it's work. Okay, now it's working. Fine. Okay, now if you have a circle like this, can you mute yourself, please, guys? Those who are not interacting with me, please mute yourself. Okay, if this is the circle on which the ship is lying, the ship could be at position A, could be at position B, could be at C, X, Y, Z, wherever it is. If it is somewhere on the arc of this circle, then this circle will be called as a position circle. So what is a position circle? A position circle is a circle on whose arc the ship may be located, the observer may be located. That is what is called as a position circle. So a position circle is any circle, the arc of which passes through the observer's position. If we want to draw, Praveen, please mute yourself unless you're talking to me, please. Praveen, mute yourself. Your mic is hissing. Praveen, can you mute yourself, please? Thank
Yes,
you.
sir.
Mute yourself, Peter. Okay. If we can obtain a position circle, it shall mean the observer is located somewhere on the circumference of the circle. Now, yesterday we learned how can we draw a unique position line, unique straight line. And we had two methods. One, if we knew a point through which to draw the line and the direction of the line, we could draw a unique line. Or if we knew 2 points through which the straight line passes, we could again draw a unique line. Likewise, from geometry learnt in the schools, we know that if I give you a sheet of paper and if I ask you people to draw a circle, everybody will draw a different circle. But if I want everybody to draw the same circle, then what do I need to tell you? I need to define the center of the circle and I need to define the radius of the circle. So if I tell everybody that this is the sheet, please draw a 2 centimeter radius circle with X as the center. Then whether A draws it, B draws it, or somebody else draws it, everybody will open their compass 2 centimeters, put at X and draw the circle. Everybody will draw the same circle. So for a unique circle to be drawn, what should you know? You should know the center of the circle and you should know the radius of the circle. If you do not know the center or the radius or both of them, you cannot draw the circle, my friend. You cannot draw a circle. Then whatever circle you draw, that will be a random circle. That will not be the circle that you want to actually draw. So you need to know these two things. We usually draw now. Yes, you can draw the full circle, but usually on the chart, we do not draw the full circle. Why? Otherwise, the chart will be unnecessarily cluttered. There will be too much of lines and marks on the thing. So we draw a small where the vessel may be located. But yes, tomorrow, if you want to draw the full circle, it's not wrong. Only thing is it will add to the confusion. So usually we draw a small arc of the circle, need based. We do not draw the full circle. But it does not mean if you've drawn a small arc on which the vessel is located, that's definitely part of the position circle. Am I clear about everything on this particular slide, guys, or anybody has anything to ask?
Yes, sir.
Okay, so we continue. What are the different methods which are used in chart work which can give us position circles? One method all of you have been using is you are getting the radar range by radar. So you get the distance of a conspicuous light, lighthouse, light vessel, raycon using the radar or the tip of the land. And then you can draw the position circle with that conspicuous object as the center on the chart and range as the radius. We can also draw the position circle by what we call as the vertical angle. We can also draw the position circle by what we call as the horizontal angle. We can also draw a position circle by raising, dipping, first sighting, or last sighting of lights. And lastly, we can get a position circle by high altitude celestial observations. So these are the various methods which could possibly be deployed based on the information available to draw the position circle on the chart. We shall run through each one of them and see them the way we saw the position lines yesterday, how each of these methods is to be used. Now, yeah, tell me better. Correct. Beta vertical angle. I'll when we go to that when we cover that in detail, I'll address this. Okay, don't worry. Now, what do we do when we draw a position circle by radar range? We measure the distance of a conspicuous object on the chart by radar, and that distance we all know is called as radar range. Then, for to draw a circle, what do you need? You need the center and you need the radius. This radar range becomes the radius, and the landmark whose distance you have taken is the center of the circle. So the position circle is then drawn on the chart with conspicuous landmark as the center and radar range as its radius. For example, let us see this one. At 2000 hours, radar range of Ballycotton Island light was 5 nautical miles. Draw the 2000-hour position circle. So first 25 Ballycotton Island light, you can see on the chart. This is the Ballycotton Island light. The distance of this light is 5 miles from my ship. So that means my ship will be on any point that is 5 miles from this light. So what do? I go to the latitude scale. This is the latitude scale here. I open my compass by 5 miles from 40 to 45 miles. This much I open. This is 5 miles. I take my compass, place it here, and draw a circle on the side of the sea because there's no point in drawing the circle on the land because my ship cannot be on the land. So with 5 mile radius, I can draw this circle and this will be the 2000 RPC. Yes or no, beta? Any doubts on this one? Correct? The ship will be somewhere on this arc. Am I right? Because whether you
Yes, sir.
take this point, this point, this point, these distances will be 5 miles because they are all the radii of this particular circle. So this is how the radar range can be used to draw the position circle. I'm sure this you have been using on the ships. So usually I don't face many problems in this, but if anybody has any doubt to clarify, please do so. Okay. Then position circle by vertical angle. Now, what is a vertical angle, guys? Let me first explain. I'll show the slides later on. If you have, let us say, a high object, a lighthouse or a tower or a radio mast or something, and you are an observer here at this point, observer, Then the angle subtended by the bottom and the top of this object here, this is the vertical angle subtended by this object at O. I'm sure you know that this angle will depend on the distance. If I go closer to the light or the object, the angle will change, angle will increase. So this vertical angle depends on my distance from the object. Secondly, this angle also depends on the height of the object. If I fix the observer's position and change the height of the object, you see, at this place O2, if the height is this red one, then the angle subtended is this much. But if I reduce the height, let us say now to this much, and observer remains at O2 only, you see the angle has changed. So the angle subtended at the observer by an object, vertical angle subtended by an object at the observer, depends on two things. So the vertical angle depends on two things. One, height of the object, and second, it depends on this distance of the observer from the object, from the object. These are the two factors on which it will depend. Now we all know that if we can measure this angle, or this angle for example, and this is the height of the object, then by trigonometry, theta, this angle is theta, let us say, tan theta will be equal to this distance, that is the range of the observer from the object. It's perpendicular upon base, no, base upon perpendicular. So base is this distance and perpendicular is no, so it is perpendicular upon, sorry, base, so it will be h upon range. And this will give you the range, the distance of the observer from the object as h upon tan theta. So if you can measure this angle, you can use it to find the distance by simple trigonometry also. Okay. Now somebody asked, what is the difference between vertical angle and vertical sextant angle? Now, okay, this is the vertical angle, but how do you measure it? I said, okay, you measure this angle. How do you measure this angle? On the ship, to measure this angle, you use sextant. Now, every sextant has its error, that like watch has an error, likewise sextant also has an error, and that is called as the index error. Now, when you measure this angle by the sextant, it will not give you this correct angle. It will give you the angle as you will read on the sextant, and that will have the component of index error in it. So the vertical angle which you read from sextant, which is read from off the sextant, is called vertical sextant angle. When this vertical sextant angle is corrected for the index error, this becomes vertical angle. Is that clear now, beta? Vertical sextant angle, when corrected for vertical angle, for say index error, becomes the vertical angle. Is that okay? Whose question was that? Raghav, is it clear? Vertical angle is, so is the actual angle. Vertical sextant angle is what you will read from the sextant. Once you correct the vertical sextant angle with index error, what you will get the correct angle, and that is what you call as the vertical angle. So it is the vertical angle that you are interested in, not the angle that you read from sextant, and the difference between. Here I have to use tan theta formula. Now we don't usually tan theta formula in our chart work. Why we do not use? I think this angle must be 90 degrees because trigonometric ratio, sine, cosine, tangent, they are applicable in right angle triangles only. Now, for this angle to be 90, the observer should be right at the base of at the same level as the base of this object. That means the observer should be at the sea level. But in reality, Is the observer at the sea level? No. The observer is on the ship. So if here is the sea level, you have an object here like this of height h, and the observer is somewhere on the ship. Observer is somewhere on the bridge of the ship. So he is not at the sea surface. Then this angle is not 90. And if this angle is not 90, use technically tan theta formula then cannot be used. Well, practically it does not make any material difference, but theoretically, yes, this is an issue. So just to be theoretically correct, we refrain from using the tan theta formula because this angle is not 90. We use another concept of geometry. I'll not go into the derivation of that. We use that formula that this angle is equal to L in radians is equal to L upon R. L is the length of the arc like this. This is the length of the arc. This is the radius. And based on that, we arrive at a formula. What is the formula? Range by vertical angle in nautical miles. Answer will be in nautical miles is equal to 1.856. Now, in some books, it's 1.856. In some books, you may have it 1.854. It does not make any difference. Okay, so don't worry about that. 1.856 into height of the object in which units? Meters. Divided by vertical angle theta in which units? In minutes. So please take note of the units. Range will be nautical miles if you use the height in meters and vertical angle in minutes. Obviously, this vertical angle will be corrected, will be the vertical sextant angle plus minus index error. Guys, we all know if index error is off the arc, we add it. If it is on the arc, we subtract it. And this is how the index error is allowed. Okay. Theta, so once we get the vertical angle after applying the index error, we convert that into minutes, becomes the denominator. What is this h? H is the height of the object above the sea. Now, does this height remain always the same? No. This height will depend on the level of the sea. If the sea level, the tide falls, the height will increase. If the level tide rises, the height of the object will decrease. So this h that you going to use here should be the height of the object at the time of observation. In our calculations, we use it from the chart. Now, if you remember the introductory part yesterday, we said the depth of the sea, the charted depths are given with respect to chart data. But the height of the objects on the chart, the charted heights, are given with respect to, if you remember, it was mean high water spring. So the charted heights are given from mean high water spring. Now, if they are given from mean high water spring and your tide is different, then you'll have to allow for that tide and get the corrected height of the object before it is used in the formula. Guys, am I clear? Whatever I have said here will be repeated in the slides, but is it clear what I have said? Or do you have any questions to ask? Class? And once you get this distance, range, it gives your distance from the object. Then once you have the range, the object becomes the center and the range becomes the radius, like the radar range. So only thing is in radar, you are getting the range from the radar. Here you are calculating the range after you have observed the vertical angle. So the method of getting the range has changed, but the concept of drawing the position circle will be the same. You'll use the center and the radius. Am I clear, class?
Yes, sir.
Clear, guys? Let me show you what is there on the slides there. Okay, here on my slide, it's 1.854. Doesn't matter whether you ate 1.856 or 1.854, it's okay. The vertical angle subtended by an object at the observer, I have already explained to you, it depends on two things. One, the height of the object, and two, the distance of the observer from the object. The vertical angle on the ship is measured by the sextant, and what you measure with the sextant is called as vertical sextant angle. The charted heights are given with reference to mean high water spring. If charted heights are used, if the heights are not given in the question and you have to use the charted height from your chart, then please, you must correct them for tidal variance with respect to mean high water spring, and thus obtain the height above the sea level at the time of making the observation. Now, then you have to learn this formula, guys. Once or twice you can refer to it, and thereafter, obviously, you will have to learn it. Range in nautical miles will be 1.854 or 1.856, doesn't matter, into height of the object in meters and vertical angle in minutes. Pay attention to the units. This 1.854 or 856 stands good only if height is taken in meters and vertical angle in minutes, where height will be equal to the height of the object above the sea level at that time, which will be charted height plus minus the correction for the tidal variance from which reference? From mean high water spring. Why? Because the charted heights are given with reference to mean high water spring. Vertical angle is equal to vertical sextant angle plus minus index error. If it is off the arc, it is plus. If it is on the arc, it is minus. And with this, we are good to see an example and draw this thing, draw our position circle by vertical angle. Yes, Harshad, tell me, what is the doubt?
Sir, I have a doubt regarding this mean high water springs.
Yeah.
What you just said.
Mhm.
If the charted heights are used, so they actually provide you with the tides or something. Is there a problem that comes regarding with
Yes,
this?
they'll have, as far as exam is concerned, they'll have to give you what is the tide from mean high water spring, right? On board the
Okay.
ship, you can calculate the tide, you would know the tide, and you can factor it in. Okay.
Okay, sir.
Okay. Guys, you don't have to raise the hand, you can unmute, and just as far as I'm concerned, I'm okay if you unmute yourself and shoot your question. Okay. So don't worry. Sometimes I may not see the raised hand. Please don't hesitate to interject and clarify your doubts. Okay. On the run. No issues at all. Okay, let's look at this question. At 1100 hours, the vertical sextant angle, it is not the vertical angle, it's vertical sextant angle of Ballycotton Island at the ship was, so you have made an observation from ship, and the angle was observed to be 0 degrees 18 minutes. Index error of the sextant was 2 minutes off the arc. At the time of observation, the tide was 1 meter below mean high water spring. Draw the 1100 hour PC by vertical angle. Now, guys, we can definitely correct. I'll show you whatever is printed. It'll keep coming, no problem. Let's first correct the and get the vertical angle. Now, this is how we'll write in our answer sheet. Vertical sextant angle 0 degrees 18 minutes. Index error of the arc. It's off the arc. Yeah, off the arc. It's so plus 2 minutes. Vertical angle will be equal to 0 degrees 20 minutes. And when I convert it into minutes, it will be only 20 minutes. This is one step I show on my answer sheet. Guys, if the vertical angle was 1 degree 5 minutes, then we will use vertical angle in the formula as 65 minutes. We'll not use it as 1 degree 5 minutes. It has to be converted into minutes. Am I very clear about it? Am I clear about it, guys?
Yes.
Vertical angle in the
Yes, sir.
formula must be used in minutes. Okay, so don't make a mistake. Then we go to the height of the object. Now, height of the object is not mentioned in the question, so we can look at the chart. Ballycotton Island light here is here. What are its characteristics? Characteristics of it are, it is written like this. Let me write down here. It's flashing white, red, 10 seconds, 59 small m, and below that it is written 22 by 18 capital M, and then it's the sound signal horn for group 4 every 90 seconds. Now guys, how do we read these characteristics? I know many of you may be knowing it perfectly fine. It's flashing what color? White, red. That means it's a sector light. In some sector it will be red, in some sector it will be white. What is the interval of between the flashes? Every flash is every 10 seconds. The frequency of the flash is 10 seconds. This 59 small m is the charted height of the light, guys. 59 meters is the charted height of the light. 22 by 18 capital M. This is the nominal range of the light. We'll talk about it in the next thing today itself. This is the nominal range. So where you have small m, that is the height of the object in meters. Okay. Now it is given as 22 by 18 capital M. What does it mean? You see, in this sequence here, WR, white comes first, red comes next. So this 22 nautical mile nominal range is for the white light, and 18 miles nominal range is for the red light. So depending on which sector you may be, if you have to use the nominal range, then you will use appropriately. If you are in white sector, you will use 22 nautical miles. If you are in red sector, you will use 18 miles. But anyway, in this topic, we are not going to use it. Here we are basically referring to the height of the object. And then the sound signal in case of fog, it's group 4 horn, group 4 every 90 seconds. This is how you'll read the characteristics. So guys, in my answer sheet, what will I say? Charted height of the belly cotton light is 59 meters. Look at the question. It says the tide was 1 meter below mean high water spring. Tide 1 meter below mean high water spring. Guys, if the tide comes down, will the height increase or decrease? Tell me.
Increase.
Increase. So that means I will
Increase.
add 1 meter
60
here.
meter.
Correct. So height that I have to use is 60 meters. So now I have the height 60 meters. I
Excuse me,
have
sir.
yeah, tell me,
Hello.
tell me,
Excuse me, sir.
tell me, beta.
This ये लास्ट जो टाइड वाला लिया आपने टाइड 1 मीटर बिलो मीन हाई वाटर सी वाटर ये एडिशनल का थोड़ा सा एक्सप्लेन करेंगे सर क्यों ऐसा प्लस किए हम इसमें
तुम बताओ, अगर टाइड मीन हाई वाटर से नीचे गिरेगा तो लाइट हाउस की हाइट बढ़ेगी या घटेगी पानी के ऊपर? इफ हियर इज द लाइट if here is the
मीन
light
हाई
and एक minute, and this is the mean high water spring,
ओके
mean this distance is 59 meters. This is the charted height. अब
ओके
लेवल अगर 1 नीचे 1 मीटर नीचे होगा तो अभी सी लेवल
बढ़ेगा
किधर
सर
है?
यस सर इंक्रीज
सी
होगा
लेवल इधर.
इंक्रीज
तो हाइट above the water will increase by 1 meter, yes or
इंक्रीज
no?
इंक्रीज यस सर ओके सर या थैंक यू सर
म्यूट कर लो फिर अपने आप को बेटा. So we have the height of
सर
60
सर
meters
ये
which will be you. Yeah, tell me.
सर ये क्वेश्चन में एवरी टाइम मीन हाई वाटर स्प्रिंग से रेफरेंस ही होगा रिगार्डिंग दिस हाइट.
कल तो क्लास में नहीं था जब चार्ट 5048 दिखाया था
हाँ सर.
राहुल. Charted heights are given from which reference?
चार्ट डेटम.
Charted heights are given from chart datum. तू देख ले, मुझे शेप में मिलेगा, फिर मैं उल्टा लटकाऊंगा तुझे. हम्म Charted heights are given from chart datum.
Charted heights are given with reference to mean high water spring.
So then
नहीं,
so
मैं वही
the
पूछ रहा हूँ सर,
हाँ
क्वेश्चन में हमेशा MHWS के रेफरेंस ही होगा.
बेटा अदर देयर विल बी इनफ इंडिकेशन इफ अगर कुछ चेंज भी करेगा तो देयर विल बी इनफ इंडिकेशन व्हिच विल टेल यू व्हाट इज द डिफरेंस फ्रॉम मीन हाई वाटर स्प्रिंग राइट अदरवाइज हाउ विल यू अलाउ फॉर इट राइट करेक्ट बेटा
Yes, sir.
ठीक है ओके म्यूट कर ले now once you get the height and you get the vertical angle you can put them in the formula and get the range प्रवीण म्यूट करो अपने आप को now the range will be equal to 1.854 I am using because in my slide it is 1.854 into a height 60 meters divided by theta in minutes 20 minutes and we'll get the range in nautical miles and using that range and Ballycotton Island as the center we can draw the position circle. So let me show you the slide. Identify the Ballycotton Island light, that is the Ballycotton Island light. Calculate the range by vertical angle. Ballycotton Island light characteristics are these. I have already explained it to you. Charted height 59 meters. Tide 1 meter below mean high water spring. So the height at the time of observation was 60 meters. Vertical sextant angle 0 degrees 18 minutes. Index error 2 minutes off the arc. Vertical angle will be 20 minutes converted to minutes. Now we put them in the formula and we get range as 5.6 miles. Is that correct? If you would like to try on your calculator, you can do so and confirm that you are okay with the calculation of the range.
Yes, sir.
Okay. Now with you'll open your compass 5.6 miles on which scale? On the latitude scale. Put your compass at Ballycotton Island light and draw the position circle. And I'm sure you'll agree this will be the position circle. Yes or no, beta? With this distance range being 5.6 miles. Correct, beta? Yes or no?
Yes, sir.
Yes, sir.
Okay. This is how we'll draw the position circle by vertical angle. So we have done two methods of drawing the position circle. One by a radar range and two by vertical angle. Now we'll move to the third method of getting the position circle. Position circle by horizontal angles. Let me first explain without showing you what is there on the slides. Guys, we just said that if this is a vertical object, then and observer is here, then this angle is the vertical angle. Now suppose this was not in the vertical plane. Suppose on the horizon of the sea, you had a lighthouse A here and you had a lighthouse B here. And suppose the observer is here. Now, if you join this line, observer to A and observer to B, this angle that will be subtended here. Now here, observer A and B are in the same horizontal plane. They are not in a vertical plane now. They are in the same horizontal plane. If they are in the same horizontal plane, then this angle is called as the horizontal angle. So is the horizontal angle clear first, beta? Clear, guys? Now, how can we get this horizontal angle? One is you can get the horizontal angle, you can measure by sextant by holding the sextant in the horizontal plane. So one you can obtain by sextant. Obviously, if you obtain by sextant, that will be called as horizontal sextant angle. And how will the horizontal sextant angle be converted to horizontal angle? In that case, horizontal angle will be horizontal sextant angle plus minus index error. So one method of getting the horizontal angle is by sextant. Okay. The second method of getting the horizontal angle is by bearings. Now, these bearings may be true bearings, may be magnetic bearings, may be compass bearings, may be relative bearings. They may be any of these. Of course, if true bearings are there, then you don't need anything. You can directly get the position. But if you get other type of bearings also, whether it is gyro, you can get the horizontal angle. I'll show it to you now. So, for example, let us say this is the compass north. Okay. Suppose here is lighthouse A. Guys, if from compass north, if I measure in the clockwise direction up to A, what will this angle be? Can you tell me what will this angle be? I've measured from compass north clockwise in direction up to the bearing line of A. What will be this angle, guys, that I have marked? Tell me. Class, what will be this? Whatever comes to your mind, speak out. Don't worry.
Compass error, sir.
No, this is not. Where is true north?
So relative compass.
Relative bearing.
No, this is not relative bearing is with respect to ship's head, beta. This is the compass bearing of A. Correct, beta? Am I right? Okay. Let us say here is lighthouse B. What will this angle be? This will be the compass bearing of B. Am I right? Yes or no?
Yes, sir.
Yes.
Now, if you subtract the two bearings, one from the other, then what do you get here? You see, if you you
Angle
get
between
this
these two.
this
Horizontal
angle,
angle.
and this angle is
Horizontal
the
angle.
horizontal angle. So the beauty of this method is that even if I don't know the compass error, even if I don't know the compass error, I can still use it to get the horizontal angle. Why? Because both the bearings are suffering from same error. If both the bearings suffer from the same error, their difference will not change. Instead of compass north, if it was gyro north, then these will be the gyro bearings. Again, you will get the horizontal angle. Instead of that, if it was magnetic north, again, this will be the horizontal angle. That means I can get the horizontal angle either by use of sextant or by finding the difference in the bearings. Is that clear to everybody? Yes or no? Clear, beta?
Yes.
Yes, sir.
Yes, sir.
Okay. Let me
Excuse me,
also
sir.
show. Yeah, tell me.
I have one query regarding this. One thing I missed. The relative you had written relative between gyro and compass.
I've still not explained the relative. Have you understood? Compass bearing, magnetic bearing, gyro bearing. Is that clear? The difference between these three will be the horizontal angle. Yes or no?
Yes, sir. That
Okay.
understood, sir.
Okay, fine.
Okay.
Now let me explain the relative bearing. Relative bearing is with respect to the ship's head. Let us say I have a ship heading like this. If I have a lighthouse A here and I join this line, this angle is the relative bearing of A. Am I right, guys? This is the relative bearing of A. Yes or no? Correct?
Yes, sir.
Yes, sir.
Now, if I mark B somewhere there, I'll also get the relative bearing of B. Let's say B is somewhere here, and I join this line. This will be the relative bearing of B. What is the difference between the two? Is it again not the horizontal angle, guys? Am I right? The difference between the two is again the horizontal angle, yes or no?
Yes, sir.
Yes, sir.
Praveen, you got your answer?
Yes, sir. Understood, sir. Understood. Yeah. Thank you,
So the beauty of this particular method is that you don't have to use sextant. You also go on your thing and use the pelorus, the graduations on the outer side of the compass repeater, and use it. Pelorus gives you relative bearings. So basically, any of these bearings can be used to obtain the horizontal angle. So first, let me take you through this, and then how the horizontal angle will be used for position circle. We'll come to that. We'll discuss that. Horizontal angle is the smaller angle and not the reflex angle. Now, guys, you see, if here is the observer, here is A, here is B. There are two angles subtended by at the observer. One is this angle, which is smaller, and other is this bigger angle, which is called as the reflex angle. We will take the horizontal angle always the smaller of the two. Okay, so that means your horizontal angle cannot be greater than 180 degrees. Why? Because the moment this angle becomes more than 180, the smaller angle will be on the other side. So we'll always take the smaller of the two. We will not use the reflex angle. So horizontal angle is the smaller angle, not the reflex angle subtended by the two conspicuous objects. Clear, beta? We have to take the smaller angle. Is that clear, class? Okay.
Yes, sir.
Yes, sir.
Now, on what parameters will this distance, will this angle depend? Now, let me also that explain to you before I show that further. Suppose here is A, here is B, and I fix this distance between A and B. Let me call this, in my discussion, this is not the correct term, but I'll call this as baseline. Baseline in chart work is altogether a different line, okay? That is a reference line, that's a datum actually. But let me just call it as the baseline for the purpose of discussion. Now you see, if A and B are fixed, now if the observer is closer to this baseline, the horizontal angle subtended will be this much. If the observer is away from the baseline, like O2, the angle subtended will be this one. And you can see here that angle 1 is greater than angle 2. That means the horizontal angle subtended by the 2 points at the observer will depend on the observer's distance from the baseline. Do you agree with me? Yes or no?
Yes, sir.
This angle will depend on the distance from the baseline. Second, it will, now if I fix the observer and I change the distance between the objects, I change the baseline. That means let the observer be at 1 only. And now instead of B, I take this point C. Now what have I done? I have reduced the length of the baseline. And now at observer 1, you see the angle has reduced. So that means the horizontal angle subtended at an observer will depend on two things. One, the length of the baseline, like AB and AC, and the distance of the observer from the baseline, like O1 and O2. So these are the two factors on which the distance of the observer from the these are the two factors on which the horizontal angle subtended by 2-point shell or on which it will depend. Okay, now we go through what is written. It has been explained. Horizontal angle is the smaller angle, not the reflex angle subtended by two conspicuous objects at the observer. The horizontal angle subtended by a pair of objects. Obviously, for horizontal angle, there have to be two objects, right? So there has to be a pair of objects at the observer will depend upon distance between the objects, like we said, A, B, and AC, or in other words, the length of the baseline. And second, it will depend on the distance of the observer from the line joining the two objects. The horizontal angle on the ship can be obtained by one, sextant. In that case, it will be called as horizontal sextant angle. And two, it can be obtained by difference between the bearings of the two objects. So any of these two methods can be used for finding the horizontal angle. If horizontal sextant angle is available, it must be corrected for index error, and then you obtain the horizontal angle. Horizontal angle is equal to horizontal sextant angle plus minus index error plus of the arc minus on the arc. Horizontal angle by bearings is obtained by taking the difference between the bearings of the two objects. Both the bearings need to be necessarily of the same time. Both must be of the same type. Either both need to be compass, both need to be gyro, both need to be magnetic, both need to be relative. That is, both may be gyro, both may be compass, both may be relative, both may be true. Though if they are true, then you don't have to use this method. You can plot the true bearings directly on the chart. If the difference between the bearings is more than 180, then you will subtract the difference from 360. Why this is required? This is required because the first point said that horizontal angle is the smaller angle and not the reflex angle. So if it is coming greater than 180, it can't be greater than 180. If the difference in bearings is coming more than 180, you can subtract the difference from 360, and that will be the horizontal angle, because then you have to get the other angle. Okay, so this is how you can use the bearings to get the horizontal angle. Now we come to the procedures. Once we have obtained the horizontal angle, how do we get the position circle? First thing is to get the horizontal angle and then to draw the position circle. Guys, the first thing we'll do is we'll get the horizontal angle. How can the horizontal angle be obtained? It can be obtained either by sextant or by difference in bearings. Once you get the horizontal angle, what will you do next? Next, you will basically subtract it from 90. You will obtain its complement, 90 minus horizontal angle. So, you'll first determine the horizontal angle, then you will subtract it from 90. You'll get 90 minus horizontal angle. Now we come to the most important part of this question. Guys, then we will join the two objects and draw the baseline. Then we draw the baseline on the chart, joining the two objects, the segment joining the two objects, and we'll call it as baseline just for the sake of discussion.
Sir, why 90 minus horizontal angle?
Because it is based on a geometry theorem, that the angle subtended by the segment of a circle, the angle subtended by a segment of a circle at the center is twice the angle subtended by it at the circumference of the circle. So it is based on that simple geometry theorem. So we are trying to apply that through these steps. In schools, we have done this better theorem, that if you have a segment like this AB, then whatever distance angle it subtends at the center, let us say this angle, and whatever angle it subtends on the circumference at A, at B, at C, at any point on this side, this angle, do 2. So angle 1 will always be twice of angle 2. Angle subtended at the center is twice the angle subtended on the circumference. So we are trying to achieve that plot through these steps. Okay, beta?
Okay, sir.
Okay. Draw the baseline on the charts, that is the segment joining the two objects. Then it comes the important point of it, without which you cannot do the question. You have to determine on which side of the baseline does the ship's position exist. You may not know the position, it's fine. If you knew the position, then you will not do this thing that we are discussing. This all is to basically get the position of the vessel. You don't know the position, I'm taking it, but you will know which side of the baseline is your ship located. When we discuss the example, we'll talk about it. So it is very, very important to establish on which side of the baseline on the chart does your ship's position lie, and then that becomes an important point for further execution of further step. Now we have to draw this angle which we obtained 90 minus horizontal angle in step 2, where at both ends of the baseline we have to draw this angle at both the ends. I'll show you through an example. Don't worry, when it is written in the text sometimes it can be confusing. When we execute, you will find that there is no problem at all. Now the issue would be this beta. Suppose there is this point A, this point B. This is the baseline. Let us say this horizontal and 90 minus horizontal angle, let us say this value is 30 degrees. Now I have to draw this 30 degrees at A also and at B also with this baseline. Now whether I draw this 30 degrees on this side or I draw 30 degrees on this side is important to figure out. Why? Because both will lead you to different results. Okay. Now, it is very important that you figure out which side of the baseline does the ship exist. That means, does the ship exist on side X of the baseline or does the ship lie on side Y of the baseline? It's very, very important. If you can't figure it out, you can't apply this method, then please look for some other method. Okay. Now, on which side should I draw? It will depend on some cases. Now, if your horizontal angle, if your horizontal angle is less than 90 degrees, then you will draw 90 minus horizontal angle on the side of the ship, on the side of ship. That means if you say my ship is on side Y and my horizontal angle was less than 90, then I'll draw this angle 30 degrees on this side like this. Like this. Where will we draw if it is greater than 90? We'll discuss that in a while from now. So first, let's focus on only this situation. What is the situation? Horizontal angle is less than 90 degrees. If horizontal angle is less than 90 degrees, then 90 minus horizontal angle will automatically come as a plus value. If this 90 minus horizontal angle is a plus value, you will draw this angle on which side? Please repeat to yourself. You will draw it on the side of the ship. It will be drawn on the side of the ship. I repeat, if 90 minus horizontal angle is a positive value, when will it be positive? When horizontal angle is less than 90. So if 90 minus horizontal angle is a positive value, this value of 90 minus horizontal angle will be drawn on the side of the ship. On whichever side the ship is, on that side of the baseline, you will draw this angle. If 90 minus horizontal angle is negative, that means horizontal angle itself is more than 90. If horizontal angle is more than 90, then 90 minus horizontal angle will give you something minus something. If 90 minus horizontal angle is a negative value, you can say like this, or you can tell yourself horizontal angle is greater than 90. Both mean the same. In that case, this angle 90 minus horizontal angle will be drawn on the opposite side to the ship. It will be drawn on the opposite side. Am I clear, guys? Am I clear? If horizontal angle is less than 90, 90 minus horizontal angle is drawn on the side of the vessel. If horizontal angle is greater than 90, it will be drawn on the opposite side. Am I clear, guys? Yes or no?
Yes, sir.
Okay, so I'll be clearing the screen and showing it to you all over again. And then all this will be clear to you once we take an example. You see, obtain the horizontal angle either by sextant or by bearings. Obtain 90 minus horizontal angle. Draw the baseline. Determine which side of the baseline does the ship lie. Draw this 90 minus horizontal angle at both ends of the baseline. Which side will you draw the angle is the issue. If the horizontal angle is less than 90, then the angle will be drawn on the side of the ship. If the horizontal angle is greater than 90, then 90 minus horizontal angle is drawn on the opposite side, opposite to the ship. Side opposite to the ship. Please remember it. This is very, very important. This has to be drawn on the correct side. If you draw it on the wrong side, it's automatically taking you to a wrong inference. Now, the point where these two angle arms will intersect. So if this was the baseline, AB, and I have drawn this angle, these are the angles drawn here, where they intersect. This will be the center of the circle that I need to draw. So the point of intersection will be the center of the circle. And from C to A or C to B, these are both equal. This will be the radius. So what will you do? You'll take your compass, put it at C, open up to A or open up to B from C, whichever you want to open. Now your compass is opened equal to the radius. Compass is already at the center. Now you will draw the circle. You will not draw in this particular method. Never draw the full circle. Draw which circle? Which part of the circle? Draw it only on the side of the ship. Why? Because the ship will be on the arc which is towards the ship. It will not be on the arc on the opposite side. So draw only that part of the circle on which the ship actually could be located. Do not draw the full circle. Distance from the center of the PC, center of position circle to either end of the baseline is the radius of the position circle. Now, whatever I have taught you, let's first revisit this through this example. Following bearings were obtained from a vessel at anchor. Old head of Kinsale 242 degrees gyro, Roche's Point 290 degrees gyro, Belly Cotton Island 037 degrees gyro. Find the anchor position and the error of the gyro. Now guys, we have 3 points. Let us say if I call them A, just for the sake of easy discussion, A, B, C. One pair, that means 2 objects, will give you 1 horizontal angle. And 1 horizontal angle gives you 1 position circle. So in 3 objects, there can be 3 pairs, AB, BC, and AC. You can pair them whichever way you want. We have to have only 2 circles to get the position. What is suggested and recommended is always pair the middle object on the chart with the 2 on each side. This is to avoid unnecessarily cluttering of your plot and avoid confusion in the plotting. What am I trying to say? Let me locate these 3 points on the chart. Here is Old Head of Kinsale, here is Roche's Point, and here is Belly Cotton Island. Look at the chart. Which is in the middle, which is in between the 2 guys? I'm sure you'll agree Roche's Point is in between, right? So what you should ideally pair is, you should pair Roche's Point with Old Head of Kinsale and Roche's Point with Belly Cotton Island. You should avoid pairing Old Head of Kinsale with Belly Cotton. Otherwise, the plot will unnecessarily confuse you. So this input or this recommendation is to avoid the confusion in the plotting. So try and pair the middle object with 1 on each side. So let's pair Roche's with Old Head of Kinsale. Now guys, the Old Head of Kinsale gyro bearing is 242. Roche's Point is 290 degrees gyro. What is the horizontal angle between them, beta? What is the horizontal angle?
48. 48 days.
48 degrees. Okay. Now, if you have doubt, then you can go to the compass rose, mark 242 here, and mark 290 here. This is the smaller arc between them. How much is this? This is 48 degrees. So you can also figure out from here what is the horizontal angle. Like this, right? Now, is the horizontal angle less than 90 or more than 90, guys? Or anyway, what will be 90 minus horizontal angle? 90 minus horizontal angle will be plus 42.
42.
Am I right? Plus 42, right?
42 degrees. Yeah.
Correct. Now let's pair Roches and Ballycotton Island. Guys, what is the horizontal angle between them? You can use the compass rose if you have a doubt. 290 is here, 290 is here, 037 is somewhere here. Now, which angle are you going to take? Are you going to take angle 1 or are you going to take angle 2? Which angle are you going to take?
73.
Smallest angle.
73
Smaller angle 1, right?
Smaller one. Yeah.
Right? So this, you see how many graduation? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It will be 107, right? Am I right, beta?
Yes, sir. 107.
Okay. So if you have a doubt, you can go to the compass rose. As long as, otherwise, how will you can do it? You can do it like this. What is the horizontal angle between them? I just subtract from 290, 37 degrees. This will be 3, this will be 5, this will be 2. It is 253, right? Now, since horizontal angle is coming more than 180, your horizontal angle can never be greater than 180. If it is coming more than 180, subtract it from 360. You don't have to say anything. You'll just say 360 minus 253 equal to 107 degrees. Is that clear, beta? You can show it like this, or you can read off from the compass rose, whichever way you are comfortable with. But horizontal angle can never be greater than 180. Is that clear? Class, is that clear? That horizontal angle is 107 degrees in this case? Yes or no?
Yes, sir.
Okay. Now, let me just discard and play it again. Okay. Now, 90 minus horizontal angle will be minus 17. Do you agree with me? 90 minus horizontal angle will be minus 17. Correct, beta? Now,
Yes, sir.
now we'll draw the position circle. First, let's draw for the first horizontal angle, Kinsale and Roches. We'll join Kinsale and Roches and we'll call it as the baseline. We join them. Okay. How much angle do I have to draw here? 42 degrees plus 42. If it is plus 42, which side should it be drawn? Towards the ship or opposite side, guys?
Towards the ship.
Towards
Okay.
the ship.
Now look at the chart. Will the ship be on side A of the baseline or side B of the baseline? Which side do you
Side
think?
B.
Side B. So now this 42 degrees will be drawn on the side B. Now, some of you may have a doubt how to use the protector also. So I don't want to unnecessarily leave anything to chance. You'll take your protector, you'll put your D here. The D would be half will be on this side, half will be on this side, and the D will be put on this side on which side you want to draw the angle. And you will measure 42 degrees here, and this will be the angle 42 degrees using the protector. Now you'll move your protector here, guys. And you'll draw 42 degrees here. Have you understood? Am I clear how this angle has to be drawn? Anybody has any doubt? Don't make mistakes when we start plotting, guys. Clear?
Yes, sir.
Excuse me, sir.
Yeah.
Sir, if see in this diagram we can easily understood.
अरे तू मेथड देख ले पहले, तू अब जितना है उतना तो एब्जॉर्ब कर ले प्रवीण पहले. Let's
Okay, sir.
run through the process. Don't worry. It's
Okay, okay, sir.
uh, don't unnecessarily get anxious. Okay, guys. So now we have to draw it towards the ship. We draw this angle 42 degrees on the side of the vessel. You have all told me the ship is on this side, so I have drawn this 42. These angles are 42. Where do they intersect? They intersect here. This will be the center of the position circle. C is the center of the position circle. Now you'll take your compass, put it at C, measure it to Kinsale or this. Both these distances will be same because these angles are same. These distances, it will be a isosceles triangle. Isosceles triangle, right? So you can open it to this point or this point. They'll both be same. And now you will not draw the full circle like this. You will not draw the full circle like this. You will draw the circle only on the side of the vessel. Vessel is on this side, so I'll draw the circle only this part of the circle. Is that clear, beta? The vessel will be only on this arc. It cannot be on the remaining arc on the other side. Am I right? Clear, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Now we deal with the second pair or second horizontal angle. It is between Roche's and belly cotton. We draw the baseline. Baseline comes in red. Now, do we draw the angle on side A or do we draw the angle on side B? Look at it and tell me.
Side A, sir.
Side
A.
A, that means opposite to the side on which the ship is, correct? Right?
Correct.
Why?
Yes, sir.
Because 90
Yes,
minus
sir.
horizontal angle is negative.
Negative.
So I draw 17 degrees on the opposite side. This will be the center of the circle. C2 is the center of the circle. With C2 as the center and radius to Roche's point or belly cotton. Again, the center may be on the other side, but the vessel can be only on this side of the baseline. So you will draw the arc only on the side of the ship. You will draw this part of the arc. Is that clear to everybody? Am I clear?
Sir.
Yes, sir.
Ship
Yes.
cannot be on the other side, so it has to be drawn only on the side of the ship. So guys, if the ship is on this red arc and ship is also on this red arc at the same time, then obviously the ship can be either here or ship can be here because these two circles are intersecting at these points. The ship cannot be on this lighthouse, obviously, for sure. So this one becomes the anchor position. Am I clear, beta?
Yes, sir.
Yes or
Yes, sir. Yes, sir. Yes, sir.
okay? This becomes the anchor position. And now the second part of the question said, find the error of the compass or the gyro error in this case. It was gyro, so gyro error they wanted. Guys, any question on plotting of these two position circles? One, where horizontal angle was less than 90, that was the blue position circle. In the second case, horizontal angle was greater than 90, that was the red position circle. Is the process of drawing these two position circles clear? Notwithstanding Praveen's doubt. Praveen, your doubt I'll keep on hold. When we do assignments, in the assignment, the question will come and then I'll address that with the question. If I address that without the question, many of you will again forget. Don't worry. Okay?
Okay, sir. Okay.
Yeah. So let's not, I'll not address that today and maybe not address in the next class or next to next class. Also, when we do the assignments, there will be a question coming to that effect. And that is the time we'll address the issue. Okay? Now, guys, then comes the question of gyro error. Different lecturers tell differently in different MTIs. I would not say right or wrong. That's a matter of perception. Many instructors say take the true bearing of all the three lighthouses from the chart, get the three errors, and get the average of it. I'm sure some of you might have been told this in some MTIs. Am I right? Correct? Why? Because when we use this anchor position, we can get the true bearing of all these three lighthouses by putting the ruler and sliding to the compass rose. Am I right, guys? We can get the true bearing of all these three lighthouses also now, once the anchor position is found, correct?
Yes, sir.
And
Yes,
then
sir, correct.
comparing with the gyro bearings, we can get the gyro error. So one way of doing it is, which some institutes they do, that get the gyro error using all the three lighthouses and take the average and give the answer. Well, I personally do not vouch that. Why? Because three errors, if you have to take, it is going to take time, and it does not really make sense that it will improve accuracy in any way. Okay. So what I would suggest to you to balance between time and everything, that from your position, you take the true bearing of the farthest point. Why I'm saying farthest point, guys? If you have 2 points very close to each other and you try to put a parallel ruler against them, and if parallel ruler is slightly misaligned, the error will be huge. If the points are far apart and you align the parallel ruler, the slight misalignment will not lead to huge error. And for that reason, what I'm suggesting is, out of the 3 points, you choose the farthest one. In this plot, the farthest one is old head of Kinsale from the anchor position. I'm talking from anchor position. So put your parallel ruler on Kinsale and the anchor position. Slide this and bring it here to the parallel compass rose. Read off the true bearing, compare it with the compass bearing, and you will get the compass gyro error. Is that clear, beta? If you want to take all the three, you can take it. I have nothing against it. There is nothing like right or wrong on that. Okay, so it's entirely your case. I would say don't waste your time. It will be unnecessarily waste of time. So from anchor position obtained, read of the true bearing of old head of Kinsale. Why? Because that is the farthest from anchor position. And then get the gyro error. Compare the true and gyro bearings and get the gyro error. Is it clear, guys? Any questions on what I have explained? You see, guys, somebody was asking why we are doing it. You see, what will happen is when this angle is 42, this is 42. How much will be this angle? It will be 180 minus 84. 180 minus 84. So that will be 96. Now this is the chord of a circle. It is subtending an angle of 96 at the center. How much will it subtend on the circumference? Half of 96. What will be half of 96? 48 degrees. So the
48.
horizontal angle between these two is 48 degrees. That is what you had in the question. Now, somebody was asking why we are doing it. We were just putting those steps in place to be able to use this theorem out here. Is that clear, Vita? So is the process of drawing the position circle by horizontal angle if theta is less than 90 and theta is more than 90? Is it clear, Vita?
Yes, sir.
Okay. Okay. Now we have, I said, your horizontal angle can be anything. Your horizontal angle can be anything from 0 to 180. That means my horizontal angle can be 0. My horizontal angle can be less than 90. My horizontal angle can be equal to 90. My horizontal angle can be greater than 90. Or my horizontal angle can be equal to 180. These are the possibilities. Out of these possibilities, the two we have discussed, when it is less than 90 and when it is greater than 90. Three others are still pending. We'll go to horizontal angle equal to 90. Guys, in our schools, we have been taught that if the angle subtended by a diameter of the circle is how much? How much is the angle subtended by the diameter of a circle on the circumference? Anybody? How much is the angle subtended by the diameter of a circle on the circumference of the circle? बोलो भाई
180 sir.
what
180
diameter beta diameter subtends 90 degrees बच्चे
90
you
degrees.
see here this is the semicircle, this is the diameter of the circle, okay, and now the angle subtended by this diameter on the circumference will be 90 degrees, correct? Yes or no? Why? Because the diameter is subtending an angle of 180 at the center. If it is subtending 180 at the center, it will subtend 90 at the circumference. Am I right? Half of it. Correct, beta?
Yes,
Yes
sir.
or no?
Yes, sir.
Yes sir. Yes.
So that means if the horizontal angle between the two objects is 90 degrees, that means the baseline AB is the diameter of the circle. And if it is the diameter of the circle, the midpoint will be the center. So what you can do in that case? Join the baseline. If horizontal angle is 90, 90 minus horizontal angle will become 0. That means if I draw 0 angle, this is only for explanation that I'm telling you. If I draw 0 angle at A, 0 angle. If I draw 0 angle at B, where are these two arrows going to meet? They're going to meet at the center, correct? This will be the center of the circle. So this becomes the diameter. So what you will do, draw the baseline, take your scale, measure AB, find the midpoint, and that's the center. Put your compass here, open the radius equal to C to A or C to B, and draw the circle on the side of the ship. Don't draw the full circle, only draw semicircle. Draw the circle on that side on which the ship exists. It's very, very important. Guys, in horizontal angle cases, if you draw the full circle, it is going to confuse you somewhere or the other. In horizontal angle case, circle should be drawn only on one side of the baseline. It should not be drawn on both sides of the baseline. Ship cannot be on both sides of the baseline. So you have to draw it only on the side of the baseline. So the special case is if horizontal angle is equal to 90, then the baseline is the diameter. Then the baseline is the diameter of the circle. You can find the center and close it out. So in this case, when horizontal angle is equal to 90, the baseline becomes the diameter of the circle. What will you do? Measure the baseline with a scale and find its midpoint. That will become the center of the circle. The midpoint is the center of the circle and its distance to the either end of the baseline forms the radius. And you can draw the circle only on the side of the vessel, not the full circle, only on the side of the vessel. So guys, 0 less than 90 equal to 90 greater than 90 equal to 180. So less than 90 understood, greater than 90 understood, is equal to 90 clear now? If the horizontal angle is 90, how do you get the position circle? Is that clear?
Yes, sir.
Okay. Guys, how did we get the horizontal angle? Without sextant, how did we get it? We got by difference in bearings. So if the horizontal angle is 0, what does it mean? If you have to get the horizontal angle by
Bearing are
bearings,
same.
bearings are same. If bearings are same,
Then in line.
then it becomes a case of transit bearings. Yes or no? Yesterday we did transit bearings. Am I right?
Yes, sir.
So when horizontal angle is 0, it becomes a case of transit bearing and it will give you a position line. It will not give you a position circle. So in a question, if somebody says the horizontal angle, why I'm saying horizontal angle 0 and calling it transit bearing? Because if a question tomorrow to confuse, I say horizontal angle between lighthouse A and B is 0, then you should not get confused. that how do I now draw the baseline? How do I draw what? It is 0. So when the horizontal angle is 0, that means the bearings are same. If bearings are same, it will become a case of transit bearing. And if it's a case of transit bearings, you do not get the PC. What do you get, guys? You get a position line. So if horizontal angle is equal to 0, it is a case of, if horizontal angle is 0, it's a case of transit bearings, and you get a PL, and you will not get a position circle. Exactly like this, guys. When the horizontal angle is 180, what does it mean? That means bearings are separated by 180. Yes or no?
Yes.
When horizontal angle is 180 means what? The bearings are separated by 180. And if bearings are separated by 180, we learned it becomes a case of reciprocal bearings. And reciprocal bearings gives you position line. It does not give you position circle. So now I have covered the full span of horizontal angles from 0 to 180. If it is 0, then it's a PL. If it's less than 180, then we draw 90 minus horizontal angle on the side of the ship and draw the PC. If it is equal to 90, then the baseline is the diameter. We draw the circle on the side of the ship. If it is greater than 90, 90 minus horizontal angle is drawn on the opposite side and we draw the PC. And if it is equal to 180, then it's a case of reciprocal bearings. We do not get a PC, we get a position line. Is the drawing of the position circle by horizontal angles clear to everybody, guys? Other than Praveen's doubt, any more doubts other than that? Leave that doubt aside. If you have anything else, let me know.
No, sir. Thank you.
Okay, guys. Now we have done radar range, we have done vertical angle, and now we have squared off horizontal angle. We have only 2 more methods left. You can take a 7 minutes break. 19:05 will start, guys. We'll continue at 19:05. You can take a small break, and 19:05 we continue with the next method. Okay, take a small break. I'm muting myself.